So your test tomorrow is on chapter 2. It's going to cover lesson 2.1 to 2.7. Now, we've taken quizzes for most of the lessons except for the last 2. So on the quiz you took for 2.1, you had to complete a pattern. And I believe you also had true-false questions. So from lesson 2.1, I'm going to be giving you a number series. And you have to find the next 2 numbers in the pattern. Now, the pattern I'm going to give you, it's not going to be like prime numbers or squares or cubes. It's going to actually have some kind of math involved. So like see here where it was times by 4 to complete the pattern. That's what your question on the test will be like. You're either going to add to complete the pattern, multiply, subtract, divide. Then you'll also have a true-false question where if it's a false answer, you got to provide a counter example. So for example, if I stated all complementary angles are congruent, is that true or false?
False.
Give me a counter example.
That's where I need your help.
Okay, so 2 angles that are complementary but they're not congruent. First of all, what is complementary? Good. So tell me 2 angles that aren't congruent, that make 90.
50 and 40.
Beautiful. So that would be your counter example.
So like 50 degree angle and 40 degree angle.
Exactly. So you could draw a picture for this counter example, or you could just say a 50 degree plus a 40.
You just like prove it wrong.
Yes. You're not trying to prove it true. If it's true, you just write the word true and move on. So you'll have a true-false question. Or 2, I'm not sure the exact number. Yes?
How many pattern ones are there?
I'm not going to go to the specifics of how many of each. But I'll tell you that there's only 1. And it's the first question, and it's a freebie, basically. It's an easy pattern question. I'm not going to go into the specific numbers of each thing. I'm just going to tell you in general what to study. So that's it from 2.1. Pattern and true-false. And again, if it's false, give me the counterexample. The counterexample could be a picture. From 2.2, and again, all of these study guides have the answers on the last page. From 2.2, this is where you need to know all of these vocab words that are in this box. Okay? I'm going to be giving you a statement. So like, for example, question number 2 might state, write this statement in if-then form. And then question number 3 is going to say, take that same statement and give me the converse. And then question number 4 is going to be, give me the inverse. And question number 5 will be, give me the contrapositive. And all of the questions are going to be based on the same statement. So know all of these vocab words. So when I say write the converse, be able to do it. When I say write the contrapositive, understand what it means and how to do it. So know all of those vocabulary words and also the biconditional statement where you put in if and only if.
What's the negation?
The negation is to put like the opposite of it. So like if I said it's raining today, and then the opposite would be it's not raining today. So you just make it opposite. Most of the time you're going to add in the word not, but if it's already got a not, you take the not out.
But then, oh wait, never.
So the contrapositive is flipping and nodding, okay? Or flipping and inversing, yes.
How many questions are going to be based on?
I'm not saying how many. It's just know all the vocab. All right, so far so good? All right. And again, here's some more. I'm not going to ask you after you write the if, then, the converse, contrapositive, all that. I'm not going to ask you to tell me if it's true or false. All I want to see is that you know how to write it in those forms. Two, 3. Here is where you need to know the law of detachment and the law of syllogism. So I'm going to give you some statements, and you have to provide me a statement based on it, another true statement. And you're either going to apply the law of syllogism or detachment, just like you did on the quiz. Similar questions. 2-4, you need to know all of the postulates. Okay, on the quiz you took, I started it out and you had to finish it. I'm not going to have questions like that, but know how to fill in a blank if that's the case. Maybe a missing word like at least, exactly, things like that. Also, be able to identify a postulate based on a diagram. So if I gave you example A here, this one it says if, and it's got a picture of a line. So a line contains at least 2 points. So it goes from the line with no points on it to then the then, and that is a line contains at least 2 points. So I am going to give you pictures like this, and you'll tell me the postulate. So you need to, again, memorize these.
So like, what would the postulate for B?
The postulate B, so
At least 2 does have to be.
so through any 3 non-collinear points, there exists one plane. So the first picture has the points with nothing around it,
It has to be word for word, right?
just in general, as close as possible. Again, you need to know these postulates because they could be a reason for a proof. Yes?
Wait, so B, it couldn't be through any 3 non-collinear points, there is exactly one. That is, and then, but wait, what about
The one below it, so like B right here, this one is through any 3 non-collinear points. This is postulate 8, but then here, a plane contains, this would be postulate 9, the one below it. So because it's got the plane, and then it's got the points in it. Yeah.
So like the ninth one says,
The ninth one says a plane contains at least 3 non-collinear points. So number 2 here, it's starting out with a plane, and then in the plane there's the 3 non-collinear points.
can you do an example of
I'll get there in a minute. Okay, so know the postulates, be able to identify from a diagram. 2-5, you need to know all of the properties. So this box right here. Again, you're going to get questions just like you did on the quiz, where I will give you an equation like if this, and then tell me, is it transitive? Is it substitution? Is it addition? Whatever it may be. So be able to identify them and also write an algebra proof. So I'm going to ask you to solve for x, and you have to tell me all the steps that you did to get to that x. So for example, if I gave you a picture like this, like let's say I drew some vertical angles here, and let's say it was 2x plus 1 and 3x minus 4. So if you can realize that these are vertical, then you could set up an algebra proof by setting 2x plus 1 equals 3x minus 4. So then here you would start by subtracting. You could either subtract the 2x or subtract the 3x. I'm going to move the 2x. So this reason would be subtraction, property of equality. Then you would show this. Next you would show the addition, property of equality. So you're going to show all of this step by step, and then over to the side you would put like subtraction, addition, and justify what you're doing each time. So it's only going to involve a couple steps for that. So be able to do an algebra proof. Then from 2-5, here is where we were doing the algebra proofs. So this is more of the algebra proofs. And you might start out with geometry and then turn it into algebra. So for 2-5, still know all the properties, be able to write an algebra proof. For example here, you started out with this equation, and then you're just going to basically solve it. Work backwards, a PEMDAS. So first thing you would do here to solve this is distribute. and that's what they showed here. Well, here, no, this is a given. Here they multiplied, so the reason was distributive. Then next, to go from this step to this step, they're subtracting the x from both sides. And they showed it here on the same line. If you want to write it underneath here, like minus x, you can show it that way. So that would be the subtraction property of equality. Then they actually showed like a simplify here. You don't have to. You could jump right to what happens here and get 2x equals 10, and then show the next step would be to divide, and then division property of equality. So basically just solving it for x is the algebra proof. Good on that one? That was the easy homework that you guys did. All right, 2, 6, and 2, 7. I'm sorry. Okay, so 2, 7, this is the geometry proofs. You need to know the theorems because they will be reasons for your proofs. So again, remember, when you are doing a proof, you need to remember everything from chapter 1. And this is going to be on every test that there is a proof. You can pull anything from any of the previous chapters. So here's a first example, and the proof is done for you. What I recommend you do is label your picture by what's given. And then that's going to help you sort of see what you've got to do. So first thing I'm going to do is look at my given here. And it was AD equals 8, BC equals 8, and BC equals CD. So I'm going to put an 8 next to AD. I'm going to put eight next to BC, and then BC is congruent to CD. So BC, I'm going to put a tick mark, and then I'm also going to put one there. Now, we already know the value of BC, so that's also going to tell us that DC is 8. So now, from there, I can see what I'm trying to prove. I'm trying to prove that AD is equal to CD. Now I can already see that, but I've got to put in the steps why. So, because they both have 8 on them.
Can you picture Matthew's song
You never can go by the pick, like it's never, you can never assume anything. You always just have to go by what's given, and you can mark the congruencies. Even though it doesn't look like it's congruent, if it's given to you in words that it's congruent, it's congruent. Okay, so basically we're trying to show that this and this and this, all three of those are the same length. We're not saying AB is equal to it, only the two sides in the top. Alex?
Why is 4 given?
Okay, what they've done is they've broken it apart. Now, on your proof, when you guys are doing this, you can have more steps than what they do, or what the next person does. You could have started out by putting the given all up at the top. You could have put step 4 up here. Now, the reason why they broke it apart was sort of to show you how the transitive property came about, because it would be right next to it. So for this one, what they ended up doing from step 1 to step 2, they ended up sort of flipping around the BC equals 8 here, and they sort of did as AD equals 8, and then if you flip this around and put 8 equals BC, that's how they got from step 1 to 2 by using transitive, because these guys canceled out. And then they went and said AD equals BC. Now, the next step from 2 to 3, I don't need to see that definition of congruence, but basically all they did was change the equal sign to a congruency symbol. And then they threw in the given again, because they're trying to tie in transitive property. So again, if you took this definition of congruence, this line here, I'm just rewriting what's there, BC, and then took the given, which was the BC is congruent to CD. Again, these cancel each other out, and then you went right to what you were trying to prove. This beginning equals this end. And again, that was for the transitive property. Transitive property is going to happen quite a bit. So that's how they develop that proof. So you will have one proof where I'm going to give you all of the statements and you will provide the reasons. And then I will give you another proof like this one where I give you a picture. I'm going to give you the given and I'm going to give you the proof, and then you're going to make your whole 2-column proof giving me the statements and the reasons. And I don't know how many points yet are going to be allocated. Just know that it is a short and sweet proof. Okay, and there's multiple of them. The pictures, when you get them, if you happen to glance at your neighbor, they're going to look the same, but they're asking you to prove something different. So you may look like you have the same proof as the person next to you, but you don't. So be careful. Keep your eyes on your own test. So for 2-7, you need to memorize all of those theorems, and this was just more geometry proofs. I believe in 2-6, it was like the segments and the angles. This one had a lot to do with the right angles congruency theorem and vertical angles congruence theorem and the linear pair postulate. So again, in 2-6 and 2-7, it was mostly proofs. So this is where the proofs are going to come from.
Would we have to write, like, you know, the postulate one we had to fill it in?
Mhm.
We have to fill it in for this too?
You're not going to have to continue the whole thing. You're not going to have to write any of these theorems. Just know which ones to use as a reason. And I think for the postulate one, that 2-4, I believe it was, it's not going to be finishing the sentence. It might be filling in a word, something like that. It'll be short. But know how to identify the postulate based on a diagram. That wasn't on your quiz, but now it's on the test. So 2-7, more examples of geometry proofs. You will have a question like exercise, for example 3, where you have to find the value of x. You'll have a question like that. You're not going to have to explain your steps, but just find what x is. And either apply their vertical angles or